Okay, so now we're going to try and solve a few problems from the book, and hopefully that clarifies some confusions that you all still have. So we're going to solve um, three problems. That's going to be number 2, number 3, and number 5. So let's start with number 2. As you can see, the consumption, the investment, tax, and government expenditure is given, and we have to solve for the goods market equilibrium. Okay, so let's come here. So we're starting with number 2. So what we know is that consumption is equals to 480 plus 0.5 YD. What else do we know? Investment is 110. Tax is 70, and G is 250. Okay, let me just check if I've got. All right, so that is everything we need to know, and we need to find the goods market equilibrium. So before you watch me solve this problem, it's always smart to pause the video and try and solve it yourself. And in fact, try and solve all three, like question 2, 3, and 5. Try and solve all three of them on your own, and then you can come here and see how I go about doing it. Okay, so part 1 is we have to find the goods market equilibrium. In the goods market, equilibrium condition is when y is equal to z. And we know that z is equal to consumption, which is 480 plus 0.5 YD plus investment plus government expenditure 250. Now this YD, of course, we can break it up into y minus d. And if we do that, what we have is y equals to 480 plus 0.5 y minus t. We know t is 70 plus 110 plus 250. And from here, it's just a matter of calculating the value of y. Hopefully, all of you can do that. And what you get is, let's see, 0.5. So you get 0.5 y equals to 480 minus 35 plus 110 plus 250. So it boils down to y equals to 805 divided by 0.5 equals to 1610. So therefore, what we know is that at the equilibrium point, y is 1610, and that's part A done. Okay, part B. We have to find the equilibrium disposable income. Okay. So disposable income is, of course, we know it's just y minus t. And we have already calculated y. T is given as 70. So at the equilibrium, the disposable income is 1540. Part C, what do we need? Let's see. Oh, no, sorry. See here. Find the equilibrium consumption. Okay. Equilibrium consumption. So consumption is given here, 480 plus 0.5 YD. Okay. So consumption is 480 plus 0.5 YD. We have calculated the value of YD, which is 1540. And I think that gives us 480 plus 770, which is 1250. And that is question number 2 solved. Okay, so now let's try and solve number 3, and let's check out the question first. So refer to the economy in problem 2. So basically everything we did here. And for the same economy, what we have to do now is calculate private savings, public savings, and investment spending. Okay, so let's start with the first one. We have to calculate the private savings. Savings, I mean, how much is your savings really? It's your take-home income, disposable income, minus your consumption. Basically, however much money you have minus how much you're consuming is how much you're saving. So YD we calculated as 1540. Consumption is 1250, so that gives us 290. This is private savings. Next is public savings. Public savings is how much the government is saving. So we've seen this before, is effectively government's revenue minus government's expenditure. So government's revenue is tax minus government's expenditure is G. So tax, remember, was 70 and G was 180. So what we get is uh, no, this isn't 180. How much was G? G was 250. Okay, so 70 minus 250, and we get minus 180. So public savings is negative, which means the government is spending more than it's earning, and which means that the economy has a budget deficit. And the next thing we have to calculate is investment spending. Okay. Investments. So what we know, investment spending I is equal to how much? Private savings plus public savings. And so that gives us private savings was 290 plus public savings is minus 180, which gives us 110, which is exactly the figure that we had. So it works out, which is proof that our calculation is correct. Number 5 is interesting. I like this problem. So let's read this. So in this chapter, we have assumed that fiscal policy variables, G and T, are independent of the level of income. Basically, what we have assumed is that value of G and T are, if you remember, exogenous. They're fixed. However, in the real world, this is not the case. Taxes typically depend on the level of income. We know that. And so they tend to be higher when income is higher. Obviously, if your income is going up, you'll be paying more tax. In this chapter so far, we have assumed that T is fixed, which is obviously a simplifying assumption, but not almost never the case. So in this problem, in number 5, we're going to examine this automatic response of tax, the fact that it's going to go up as our incomes go up or go down as income go down, and see if it can help reduce the impact of change in autonomous spending. Okay, so we have these 3 questions. So let me just write this 3 down, and then I can maybe explain a bit more. So number 5A, what we have is consumption equals to C0, which is the autonomous consumption, plus C1, which is MPC, marginal propensity to consume, times YD, or I'm just going to write Y minus T. What we also have is for tax, this is no longer fixed. What we have is T naught plus T1y. Okay, so let me explain what this means. T naught is a fixed tax that everyone pays. So for example, if you live in Dhaka, you have to pay something called a municipal city tax. That's 5,000 Dhaka every year. So regardless of who you are, where you live, as long as you live within Dhaka, you have to pay this amount of tax. But on top of that, you also have to pay an income tax, which depends on your income. So suppose TI is zero point 0.2. That means however much your income is, which is Y, you're going to pay 20% of that as tax plus the fixed portion, the T naught. So this is a more realistic scenario than just holding T as fixed. And what else did we have? We had YD equals to Y minus T. So that's fine. What we have to do is solve for equilibrium outcome. Okay, we have to find the equilibrium. So let me just write down the equation for Z, which is C plus I plus G, which will give us C naught plus C1 y minus t plus I plus g. Those are fixed, obviously. C naught plus C1y minus C1t plus I plus g. But now notice that we can break t down. So C naught plus C1y minus C1t can be broken up into T naught plus T1y plus I plus g. And so, we'll simplify this more. And what do we end up with? C naught plus C1y minus C1t naught minus C1t1y plus I plus g. And so we have y equal to z on this side. So suppose y. So let's take all the y's, this and this on the other side. So what we are going to end up with is y minus c1y plus c1t1y. That is equal to c naught minus c1t naught plus I plus g. And if we simplify this side, what we will get is 1 minus C1 plus C1 dy equal to what we had. And so effectively what we get is y equals to 1 divided by 1 minus C1 plus C1t, C naught minus C1 t naught plus I plus g. So you see the structure of this equilibrium is same to the old equilibrium. So over here we have the autonomous part of our spending. This does not depend on income. And over here we have the multiplier. So our multiplier used to be 1 divided by 1 minus C1. So now we just have an additional part. I'm just writing this in new ink so that it's easier to notice. That's the new part. And this is our equilibrium output. So this is autonomous part, and this is the multiplier. Okay, so this is part A. Let's move on to part B and see what we have to find out. What is the multiplier? Does the economy respond more to change in autonomous spending? 20. Okay, okay, all right. So first of all, what is the multiplier? So let's just write that down. Multiplier is 1 divided by 1 minus C1 plus C1D. Okay. The next question is that, okay, notice this. If we assume that T is equal to 0, then we go back to our old multiplier, 1 by 1 minus C1 and nothing else. So this is the old multiplier that we had. So the question is that if, where's the question? If T is 0, what happens to the multiplier? Okay, so let's assume, for the sake of simplicity, let's assume that we have a C1 of 0.5. That's actually what we had in question number 2, I think. Right. So this was C1, which was 0.5. So if C1 is 0.5 and T is 0, in that case, our multiplier is 1 divided by 1 minus 0.5 is 2. Okay. However, if T is not equals to 0, so we have C1 equals to 0.5 and T is equal to, let's assume T is 0.5 as well. In that case, what is the multiplier? We have 1 divided by 1 minus 0.5 plus 0.5 multiplied by 0.5. And what do we get here then? We are going to get 0.25. We're going to get 1.33. Okay. So when T is equal to 0, the bigger highlighter. When T is equal to 0, multiplier is 2. When T is not 0, multiplier is less. And we can take any value of T really. Notice T is the rate of tax. So over here, we've assumed tax is 50%, 0.5. It can be 20%, it can be 90%, it can be anything. Whatever that rate is, we're going to see that the value of the multiplier is going down. Okay. And so the question is, why might that be so? I think that's okay. So here's how multipliers work. Okay, so let's look at this scenario first, where we do not have T, or rather T is equals to 0. So what we have is C1, which is 0.5. Okay, so suppose I spend 100. Okay. What the multiplier does is make sure that when I spend 100 taka, the overall effect on the economy is more than 100. How does that make sense? Once I've spent this 100 taka, I've given this money to someone. Who have I given this money to? To a producer. But this producer is also a consumer. He takes this 100 taka. His C1 is 0.5, which means out of this 100 in income, he is going to save 50%. He is going to spend 50%. So he spends 50. But where does this 50 taka go to? It goes to another producer. It goes to producer number 2, who is also ultimately a consumer. He's going to take this 50 taka income. He's going to save 50%, and he's going to spend 50%. And where is this 25 going to? It's going to producer number 3, who's going to do the same thing. He's going to save 50%, he's going to spend 50%, and so on and so forth. And this is going to go on. And if we add all of these numbers up, what we are going to see is that the overall effect on the economy is 200. And that's what the multiplier is. What the multiplier effectively tells us that if I initially spend 100 taka, the overall effect on the economy is going to be more than 100. It's going to be 100 multiplied by 2, which gives us 200. Okay, but now, well, okay, before I move on to the next part, notice that this applies in the opposite direction as well. So it would look like high multiplier is a very good thing because it helps us increase output very easily. It helps us increase the GDP, which should be a good thing. But it's also true in the opposite direction. Suppose I decide that from next month, I'm going to spend 100 taka less than what I usually spend. And if I do that, the overall reduction in output in the economy is going to be more than that 100. So in whichever direction the economy is moving, the multiplier, well, it multiplies that effect. So good becomes very good, but bad also becomes very bad. Okay, all right. Okay, now let us introduce t. So we were assuming t is equals to 0, but now let's say t is 0.5. So we have c1 equals to 0.5, but t is also equals to 0.5, which is effectively we're paying 50% tax. Okay, now what happens? I spend 100 taka. I give this 100 to producer 1. To producer 1, he has an income of 100. Out of this, he has to pay as tax 50%. So he has 50 left, which is his disposable income. Out of his 50 taka disposable income, how much is he going to spend? He's going to spend 50% because that's C1. So he spends 25. Where does this 25 goes to? It goes to producer number 2, who has made an income of 25. So he must pay 50% tax. So he has 12.5 left. Out of this 12.5 disposable income, he's going to spend 50%, which is 6.25, and so on. And this goes on. And if we add all of this up, what we are going to see is that overall effect is 133. So what has happened? In both cases, I spent 100 taka, but when there was no tax rate, overall effect on the economy was 200. But once we've introduced the tax rate, the effect is 133, which is what we had seen. Initially, we had a multiplier of 2, but then once we introduce t, we get a multiplier of 1.33. Why might that be the case? That's because when you have to pay tax, your multiplier is, let's say it's reduced. However much income you're making, you can't spend that because you have to pay a tax, which means your disposable income is gone. And if your disposable income continues to go down, you can't spend as much as you were initially spending. And that's why the multiplier is falling. Okay, so what I will ask you guys to run this same thing, but change this value of your marginal propensity to consume, change this value of tax rate, and just look at what happens to the economy. And as you play around with these numbers, you increase them, you decrease them, see what happens, your understanding of this will become better. All right, so these are the 3 problems that we were going to do from this chapter, number 2, 3, and 5. Now let's talk about the assignment. So assignment from this chapter, you're going to have to do question number 1, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 1 eat 9, and 10. And this is due on our 8th lecture. All right, so there's going to be assignments from every chapter we do. So by the 8th lecture, we will have done chapter 3, 4, and 5. So there will be, this is assignment 1, but effectively on the 8th lecture, assignment 1, 2, and 3 will all be due. All right, so don't wait until the 8th lecture because it seems like a month away and you have a lot of time left. It's best to get started immediately.